So welcome back. Question number 4. So a bullet of mass is 0.02 kg is fired with a velocity of 300 meters per second, and it comes to rest after penetrating the wood is 0.1 meter into the wood. So find the resistive force. Assume the uniform deceleration. Assume there is uniform deceleration, like there is uniform deceleration when the bullet is stopping. So set solution. Use v square is equals to u square plus 2s, and this is gotten from equation of motion, as we already know from the previous class. So with a final velocity, v is equal to 0 because it eventually stopped. So and the initial velocity, because it's not starting from rest, of 300 meter per second, so, and the distance s is 0.1 meter. So we have 0 equals to 300 square plus 2a into bracket 0.1. So we make our a subject the formula. You have a is equals to 300 square over 2 times 0.1. So we have 90,000, which is 300 square over 0.2. Note this minus is due to, I'll tell you guys when I'm done. I wrote it at the back of this sheet so you can see it. So a is equals to, because I know someone will be curious why do we have that minus. So the acceleration is equals to minus 4,500 minus 450,000 meter per second square. So note the negative sign indicates the force oppose the bullet, because oppose the bullet motion. The bullet is going into it. Why? The negative sign indicates the force oppose the bullet motion, because it's going into the wood, in which the wood now oppose the motion of the bullet, stopping the bullet from penetrating. So you couldn't penetrate outside. He penetrates, but he is being stuck at the middle of the wood. So it's showing that the motion of that force is being opposed. So the magnitude is 9,000. The resistive force is 9,000. The opposing motion. I think we got this. So it's showing that the force is being opposed. So now we go to the next question, which is question 5. Said a man of mass 60 kg stand in a lift, accelerating upward at 2 meters per second square. Now find its apparent weight, like normal force, using g is equals to 9.8. So how do you solve this question? So this and a elevator question. So in upward accelerating elevator, the formula will be the normal force is equals to the force due to gravity and the applied force, the accelerating force. So which is n minus mg is equals to ma. So to get our normal force, the apparent force, to be the ma plus the mg. So that's due to gravity and the normal force. So or the normal normal force or the normal weight. So n is equals to, m is here, we can factorize m. So that's m into bracket g plus t. So when we have an upward moving elevator, we use this formula. Now our n is equals to our n, which is 60, into bracket 9.8 plus our a, which is 2. So adding this together, we'll be having 60 times 11.8, and that's 708 Newton per Newton meter. 708 Newton. Sorry for that. So the apparent weight is equals to 708 Newton. Okay, 708 Newton. So that's how to calculate on elevator. So when it's actually moving upward. So with this, we have come to the end of dynamic as a topic. So but it doesn't stop us from practicing more questions. You can pause the videos and re-practice those questions on your own to check how much you understand each question and how those formulas are being practiced. So for now, we have come to the end of dynamic, but in the next coming videos, we may later solve questions
using some other formulas in dynamic, so to see how much we have covered and to have a better understanding of the course. Okay, thank you. Kindly like, subscribe to my channel for more latest videos, more on other topics. Thank you very much.